So, hi everyone, myself Aman, and I welcome you on today on the brand new series. So, from today onwards, we are going to start one of the most important topic from interview perspective, and not from coding much, but from interview perspective, it's extremely important. That is recursion. Okay, I hope most of you have heard this name, recursion, and so many candidate get a lot of confusion in it, that because it slightly complex, slightly not too much complex, slightly tricky, but if you focus and try to learn what I'm trying to communicate, it will be quite easy for you. Okay, so before I start, I would highly encourage you to subscribe to my channel so that any new video comes, you will get notified, and click on the notification icon. Okay, so let's start with recursion. Okay, so what is recursion? So recursion is basically, I am writing, when a function when a function calls itself when a function calls itself until a condition specified condition is met. Okay, so it's a very important line. When a function calls itself, whenever any function, we will see what it means. So it consists of basically two part. First part is when a function call itself until a specified condition is met. So this is the second part. Okay, so this is, you can say, a part 1, and this part you can say a part 2, right? So what is mean by function call itself? So let's take an example of it. So suppose there is any function, this is the function body, and suppose this is the function, and this is the function body. I think, let me, this is the function. Okay, and just give me 1 minute. This is the function, and just give me 1 minute. I think something is happening to it. What has been clicked? Let's wait. Now it's working properly. Okay, so this is a function, fine, and suppose here is another function, same function. So as you can see here, this function is calling to itself. Okay, when a function call itself, let's see one more example. Suppose I take void f. Language can be any, whichever language. I am going to make you learn through Python. Okay, here Python is our first language, so you can use any language. Okay, and this is void simply used in C++ or in Java. So just for understanding, I am teaching you. Suppose void is a function, it contains certain element, you can say, and here is one more function. Main is a body of the function, and inside main you have written this function. Okay, now inside the main, if I talk inside the void, I am writing print Aman. Okay, print Aman, and here I am mentioning f. Fine, so clearly you can see that this function will go to this function, and this will go here. Are you understanding the flow? So first, as we all know, the first is what? First is the main part of the function where you have written the main. So this is the main. So inside main, we are calling the function f. We are calling this function, right? So this function will point to this function. Okay, then inside this it will going to print Aman. So if I talk about you output, first it will going to print Aman. Then you can see another, in the next line it is calling another f, right? So if I go slightly on the right side, so what is going to happen? Suppose there is another function void f, right? Here it is written print Aman. Okay, then here another function, then I am closing it, then again I am writing void f, then I am print Aman f. So this function is basically going to point to this function. Okay, then again the same process repeating. Okay, again the same process repeating. It will going to print again Aman, then it will again point to this function, so it's going to point to another function. So basically function calling itself. Now interestingly, if we are not putting any restriction to it, it will going to be continuous process, right? It will not going to stop. So we want certain termination condition, otherwise your function, your entire code will run into an infinite loop and it is never going to end. So that's what the second statement comes in. So when a function call itself until a specified condition is met, okay, means the function will start calling until and unless a certain specified condition is met. Once that specified condition is met, okay, then the function will stop, then this whole process will stop, because ultimately if you see practically we have to terminate it, right? Otherwise it will run into an infinite loop. Now this specified condition, we called it as a base condition. What we called it as a base condition. So what is recursion? When a function call itself until the specified condition is met. So this is basically a concept of recursion. So function keep calling and there must be certain base condition. So whenever you see code, okay, and whenever you see any base condition, you will come to know means this is a example of recursion. We will see how this happening. So up till now, if I have to summarize, means algorithmically what are the steps involved in recursion. So if I say step 1, define a base class, right? Then you talk about step 2. In step 2 you define a recursive class, right? Class, or you can say case. Class is not the right word, you can say it as a case. Okay, so first is the base case, because base case will tell you means what is the terminating condition. Another thing is you define a recursive case, right? What is happening? You define a recursive case. Ensure the recursion terminates. What is happening? Okay. Just a minute. Ensure the recursion terminates. Okay, that is the most important step in recursion, otherwise your code will run into infinite loop. Okay, then you combine the solution. You combine the solution. Okay, so this is basically a 4-step process in recursion. So up till now what we have studied, let me give you a quick revision. So what is recursion? Recursion is when a function call itself until a specified condition is met, that is called recursion. I am repeating again and again so that it will be more clearer to you, right? And the base specified condition is your base condition. Here I have given try to explain you pseudo code. We have learned that how the function is calling. Now if we are not giving any base condition, then function will not terminate, right? So this is a 4-step process, typically how recursion works. Now let's look one example of it. Okay, so it will be much clearer. I will try to explain as much as I can with the best of my ability, okay, to give you good clarity. Okay, so we are going to solve also a lot of problems, a lot of lead code questions and DSA problems. So just have patience and keep learning. So let's take one example. Suppose you have to write a code, sum of first and natural number. Fine. Sum of first and natural number. Mathematically, what is we required? We want to calculate this, right? Sum of first and natural number. So let me represent it in this way. Okay, so let me go with method 1. So method 1 is without using recursion, right? So this method which I have written here is the first method, means how you are going to add it. Just simply you going to add it. So it means n plus 1 by 2. This is the standard output which we get. Okay, we used to study from school days. I hope you are clear. So this is a method 1, just simply adding it, you will get a first natural number. Method 2 is of using recursion. Method 2 is using recursion. How you are going to use it? So I am defining the function in such a way that f of n, right, is equal to 1 whenever n equal to 1, and f of n is equal to n plus f of n minus 1 whenever n is greater than 1. Very important. Let us retest it. Okay, let us test it. Okay, so suppose your n equal to 1. Okay, so for n equal to 1, right, it is given f of 1 equal to 1. So we get the output 1. Now suppose your n equal to 2. Okay, now n equal to 2, it will going to point out here because n is greater than 1. Okay, so what it will give? F of n equal to n plus f of n minus 1. So it means f of 2 is equal to 2 plus f of 2 minus 1. So here we are writing f of 2 is equal to 2 plus f of 2 minus 1, that is f of 1. Now we know that f of 1 here is 1. Put this value here. So f of 2 is equal to 2 plus 1, that is 3. That means your f of 2 is equal to 3. Okay, if we are going to do it with method 1, then you can say 1 plus 2, 2 element, so we are getting 3. Clear? Now let's move to n equal to 3. Take one more example, n equal to 3. Let's try whether it's working or not. Okay, so you have f of n is equal to n plus f of n minus 1. So let's put f of 3 is equal to 3 plus f of 3 minus 1. Right, now f of 3 is equal to 3 plus f of 3 minus 1, that is f of 2. Clearly, now f of 2 we have right now, just now we have calculated f of 2 equal to 3. So put this here. Okay, so f of 3 is equal to 3 plus 3, that is 6. So we can say that f of 3 equal to 6. If we go with method 1, then you can check 1 plus 2 plus 3, 6, f of 3. Okay, so I hope that is pretty much clear how this recursively adding it. Okay, the second method is with the help of recursion. Now one more question comes that how our recursion function. Question is how are the recursion function stored in memory, means how they are stored in memory. So one first most important thing is you have to keep in mind that recursion usually take more memory. That's why from project perspective of view, whenever you are writing a code, recursion is not a recommended approach to write your code using recursion. First one, it uses more memory. so it's not good with memory management. Okay, another thing is that it increases the complexity. It increases the complexity of the code. Okay, now what I mean with increasing the complexity, suppose you are working in a project and there are 8 to 10 developers. Suppose one developer is written a code, and suppose that developer is going on leave, and certain bug came. Okay, certain bug came, and what that developer is not there who has written the actual code using recursion, so that work will be assigned to another developer. So since he is going to debug, means what is that developer has written. So if it is written using recursion, then typically it takes a lot of time to debug, means where the issue lies. So basically the complexity level increases here, right? So coming back to the point, how a recursion function is stored. So basically recursion function works on the concept of LIFO. Okay, basically it stored in using stack. So stack is also one type of linear data structure. What is a linear data structure? We are going to study this in detail. It is also one type of linear data structure which works on the concept of LIFO. What is the meaning of LIFO? That is last in first out. Okay, last in first out. LIFO. Okay, or you can say it as a philo, means first in last out. Okay, first in last out. So if I talk about LIFO, that is last in first out, so let's take an example of it. Suppose this is one container. So here 3 elements are there, A, B, C. Clearly you can see that this is the latest element that get entry in this container. So it is going to, so whenever we are going to take out the element, this one will be the first element to be taken out. Okay, so we can say last in, it entered last in the series and it is coming out first. Okay, so here it means that is last in first out. Okay, so last in first out. So first C will come, then B, then A. Okay, so this is typically called, what we call that is LIFO, last in first out. And to insert the element in an array or any other data structure, we use the terminology push. So push means you are inserting it. Okay, and to taking out, you are popping it. So basically it is push and pop. Okay, it is called push and pop. Now another thing, so this is the one thing we address. Another question that comes very important with recursion. Okay, another question that comes with recursion is that what is base condition in recursion. So as we discussed, that base condition is typically a termination condition, means until when your loop will run, right? Once that base condition is met, the loop will terminate. Why we have to do? Because if we are not providing a base condition, then your code will run into an infinite loop, never ending loop, which we don't want as a developer, right? So if I take you one example, so let's give you one example. Suppose I am writing a code, factorial code. Okay, int fact if n is less than equal to 1, okay, then you just return 1. Okay, else return n cross fact n minus 1. What it means? So here clearly you can see that this is your base case. This is your base case. Suppose you have given an input 0. Okay, now for 0, clearly it is less than 1. It should return 1. And we also know that 0 factorial is 1. 1 factorial is also 1. Okay, so here if input is 1, okay, then it is also satisfying this condition, then it will going to return 1. Okay, so this is what we called as a base condition, base case you can say. Okay. Now typically if someone say that how you approach a problem with the help of recursion, means how you trying to solve it with the help of recursion, any problem statement. So just remember a typical workflow in your mind. First you have to break a problem. Okay, break a problem. We are going to see from practically with coding from examples, so no need to worry about it. This is from your conceptual understanding point of view, so you develop a little bit mindset about recursion. So you break a problem into a smaller sub problem. Okay, you break a problem into smaller sub problem. Okay, and add one or more base case to stop the recursion. Are you getting it? So break a problem into a smaller sub problem and add one or more base case to stop the recursion. Right now, I hope that's pretty much clear. So in this session we study what is recursion, what is base condition, what will happen that if we are not providing a base condition, how to do recursion we have learned using a pseudocode, and how a recursion function is stored in memory that we learned, and why it is not advisable to write a code in a practical environment using recursion. Okay, and typical workflow, how to solve a problem using recursion. I hope you like the session. If you're facing any challenges, just rewatch the video. Okay, so you will get more clarity. In the coming session I will be continuing from here. Okay, and we will go ahead with the discussion on recursion. Still there are a lot of things, then we will solve a coding problem, we will try to debug it, and yeah, a lot more to come. So do subscribe to my channel, and yeah, thank you, thanks for watching.